Listen to part of a lecture in a geology class.
Okay, today we're going to discuss the four major types of drainage patterns. I trust you've already read the chapter, so you'll recall that a drainage pattern is the arrangement of channels that carry water in an area. And these patterns can be very distinctive since they're determined by the climate, the topography, and the composition of the rock that underlies the formations. So consequently, we can see that a drainage pattern is really a good visual summary of the characteristics of a particular region, both geologically and climatically. In other words, when we look at drainage patterns, we can draw conclusions about the structural formation and relief of the land as well as the climate. Now, all drainage systems are composed of an interconnected network of streams, and when we view them together, they form distinctive patterns. Although there are at least 7 identifiable kinds of drainage patterns, for our purposes we're going to limit our study to the 4 major types. Probably the most familiar pattern is the dendritic drainage pattern. This is a stream that looks like the branches of a tree. Here's an example of a dendritic pattern. As you can see, it's similar to many systems in nature. In addition to the structure of a tree, it also resembles the human circulation system. This is a very efficient drainage system because the overall length of any one branch is fairly short, and there are many branches, so that allows the water to flow quickly and efficiently from the source or sources. Okay, let's look at the next example. This drainage pattern is referred to as a radial pattern. Notice how the streams flow from a central point. This is usually a high mountain or a volcano. It kind of looks like the spokes that radiate out from the hub of a wheel. When we see a radial pattern, we know that the areas experienced uplift and that the direction of the drainage is down the slopes of a relatively isolated central point. Going back to the dendritic for a moment, the pattern's determined by the direction of the slope of the land, but the streams flow in more or less the same direction, and so it's unlike the radial that had multiple directions of flow from the highest point. Now this pattern is very different from either the dendritic or the radial. This is called a rectangular pattern, and I think you can see why. Just look at all of those right-angle turns. The rectangle pattern is typical of a landscape that's been formed by fractured joints and faults, and because this broken rock is eroded more easily than unbroken rock, stream beds are carved along the jointed bedrock. Finally, we have the trellis pattern. And here in this example, you can see quite clearly how the tributaries of an almost parallel structure drain into valleys and form the appearance of a garden trellis. This pattern forms in areas where there are alternating bands of variable resistance. And by that, I mean that the bands of rock that are very strong and resistant to erosion alternate with bands of rock that are weak and easily eroded. This often happens when a horizontal plane folds and outcroppings appear. So, as I said, as a whole, these patterns are dictated by the structure and relief of the land. The kinds of rocks on which the streams are developed, the structural pattern of the folds, faults, and uplift will usually determine a drainage system. However, I should also mention that drainage patterns can occasionally appear to be, well, out of sync with the landscape. And this can happen when a stream flows over older structures that have been uncovered by erosion, or when a stream keeps its original drainage system when rocks are uplifted. So, when that happens, the pattern appears to be contrary to the expected course of the stream. But I'm interested in your understanding the basic drainage system, so I don't plan to trick you with test questions about exceptional patterns. But I expect you to know that exceptions to the patterns can occur when geological events influence them.